So now that we understand the intuition behind our regression algorithm, we can run and evaluate our regression. We will write the Python code to actually crunch the numbers. So I hope that at this point you still have your Jupyter Notebook open and your session is still connected. While the big advantage of using the online version of Jupyter Notebook is that you can get started right away and you don't have to install anything, but if you're inactive for a while and you haven't been using it, then it's possible that you can get disconnected and lose your work. So in that case, you might see something like this. And it's important to remember that you can always save your work by saying download as and then notebook. And you can always restore your work by going back to try Jupyter with Python and then simply uploading the Jupyter Notebook that you downloaded previously and your data file. So if you upload those, then you can continue where you left off. In the next module, I will walk you through how to install Jupyter locally on your machine. You might only encounter this situation if you're trying it out using Binder through the web portal. Now, without further ado, let's give our notebook the capability to run a regression. This capability, just like the others, is going to come from a module. In this case, this module is going to be called scikit-learn. Scikit-learn is one of the most popular machine learning modules in Python. And we can get hold of it in our Jupyter Notebook simply by typing import sklearn. But we're only looking for something very specific out of scikit-learn. So instead of importing all of scikit-learn, what we're going to do instead is we're going to say from sklearn.linear_model, and I hit tab on my keyboard here to bring up this option. We're going to import linear regression. Once again, I typed the first few characters there and then I hit enter to insert the rest of the code. And this avoids any sort of typos, like, having a lowercase r here, for example. After we've added this line of code, let's hit Shift Enter on our keyboard or click Run to run the cell. Alternatively, if you've opened this notebook from fresh, you might have to go to Cell and then Run All. Let me add a few more cells here at the bottom, and then we can add the code to run our linear regression. The task of running a linear regression for calculating the slope of our line and the intercepts is once more going to be done by an object. So we're going to create this object and we're going to give it a name. So I'm going to call it regression, and I'm going to set it equal to linear regression with some parentheses at the end. This bit of code here will create our object, and we're going to be storing it inside here. So we can always refer to our linear regression by the name regression. So now that we've created our object, we can actually tell it to do something. We can tell it to run our regression. And the way we're going to do that is simply by using the regression and then putting a dot after it and then writing fit. And inside the parentheses, we have to tell it two things, namely the features, our x, and our labels, our lowercase y. When we hit Shift Enter on the cell, it will crunch the numbers. And just like that, we've actually run our regression. Now, I know we don't see any output here, but trust me, the numbers have been crunched. And to prove this, we can pull up the slope coefficient and the intercept that were calculated by our regression. We can get hold of the slope through our regression object. So regression.coef, and here I'm hitting tab on my keyboard to bring up that menu there, and then I hit enter to insert the code. Now, you can of course type this out and you'll get the same result, but just remember that there's an underscore here at the end that's part of the name. So let me run this cell and let's take a look at what the slope coefficient is. So here we see that it's 3.11. Now, one of the great things about Jupyter Notebook is that we can add some markdown cells. So I can add a cell here and I can change it to markdown to add a little bit of explanation to what my code is doing. That way, if I come back to this notebook in the future and I'm wondering what regression.coef does, I can look at the markdown cell above and I can leave myself a little note. For example, I can say slope coefficient and hit Shift Enter, and then I'll get this text inserted here. Now, if I wanted to leave myself little notes inside the actual cells where I've got my Python code, then I have to use something called a comment. And I can add a comment here with a hashtag or a pound symbol. And I can add this here and write, for example, theta_1. And you can see that the text here is green. And that means that this text is considered to be a comment and will be ignored. It's not going to be treated as code. And I can actually execute the cell and it'll run just fine. But if I were to delete this little symbol here, this pound symbol, and try to run it, then I would get an error and it would tell me invalid syntax. So that little pound symbol is very, very important. That's what's going to differentiate code from comments. Okay, so we've got our slope coefficient. What about our intercept? Our intercept we can pull up similarly through this regression object. So regression dot, and then put intercept with the underscore at the end. Once again, I hit tab on my keyboard there. I'm not such a fast typer, and it inserted the code for me. So let's take a look at what the value of this intercept is. Here we can see that it's about negative 7.2 million. So now we know the regression slope and the intercept. And while it's not bad to have these two numbers to hand, we can actually do better than this. Wouldn't it be nice if we could just plot a line on our chart? Because we've painstakingly visualized our data. Why not just plot the regression line on this chart as well? So let's do just that. What I'm going to do is I'm actually going to take this entire cell and I'm going to copy it. And then I'm going to come down here and I'm going to paste it. And the reason I'm doing this is simply to have a reference. So here I'm going to have the chart without the line, and here I'm going to modify my code here so I get the chart with the line. And you can move these cells around as well. So if I use this little up arrow here, then I can move it above this cell here. Wonderful. So how do we plot a line on here? Well, we can use matplotlib once again. So matplotlib has a functionality called plot. So plt.plot will allow us to plot a line on this chart. But we have to supply some information. We have to tell matplotlib what exactly to plot. And for that, it will actually need two things. It will need the x's and the y's. So it'll need some information for where it should plot things on this axis and where it should plot things on this axis. Now, our production budgets are our feature. So for this axis, we can use our x's, right? So I'm going to put an x here and then a comma, and now I have to supply the y value. And what should this be? We don't want to use the actual value that we have for the gross revenue. Instead, what we would like to do is we want to use the predicted value from our regression. And we can get hold of those values by calculating a predicted value for each of the x values. To do that, we'll need the regression object from scikit-learn that we used earlier. All we need to do is type regression.predict parentheses x. Then it will calculate a prediction for each of the budget values in our data and plot it on the graph. So let me hit Shift Enter on the cell and let's take a look at what we've got. Scrolling down, I can see we've got a regression line right here. Fantastic. But it'd be a bit nicer if it stood out a little more, right? Let's give it a color. Let's give it a width. Let's make it a bit thicker. And we can do that by going into this line of code here. And just before this ending parenthesis, we're going to add a comma, and then we're going to add a color here. So we're going to say color is equal to red in single quotes. And that will make our line red, as you can guess. And to make it thicker, we can specify the line width. So line width, all in lowercase in one word, is equal to, let's try 4. If I hit Shift Enter to refresh my cell, then I can see that my regression line now is a lot thicker and it's changed in color. What we see now is we see the relationship between our production budgets and our movie revenue as predicted by our linear regression model. And that means we can move on to the final part of our data science workflow, namely evaluating and analyzing our algorithm's performance. How did we do? Did we do a good job or a bad job? What can the movie's budgets tell us about the movie revenue? this is the point where we have to think very, very hard about our model. The question that we should ask ourselves at this point is, are these parameters actually plausible? Let's take a look at that slope coefficient. It's 3.11. It means that there's a positive relationship between budget and revenue. And not only that, it means that for each dollar that we spend on producing the movie, we should get around $3.1 in revenue in return. And I actually think this seems to make sense. Bigger budget films tend to do better, so that's good news for us, right? Because we've put our life savings on the line for this zombie movie, right? Now what about the other parameter? The intercept. This one is at minus 7.2 million. How do we interpret that? What this intercept is literally telling us is that a movie with a budget of 0 would actually lose over $7 million. So that's a bit problematic, right? That seems quite unrealistic. Because if you and I went out to make a movie with $1,000, it's pretty unlikely that 7 million would just disappear from our bank accounts. So this is a lot less realistic. And this begs the question, what should we conclude about our model? Well, it means that we should actually take it with a grain of salt. We just have to accept that our model is a dramatic simplification of the real world. And as such, we should be a little bit careful on how much we believe the predictions of our model, especially at the extreme ends. Just look at the distance here. Look at the gap between this data point and our line. The predictions of our model seem to fit the data a lot worse at the extreme. So how would we use this model to make a prediction anyhow? Say we need to predict the revenue for a film with a $50 million budget. We know what our intercepts are. We know what the theta 0 and the theta 1 is equal to. And if we want to know what the revenue would be for a film with a budget of 50 million, all we would have to do is to substitute the values of our parameters that we estimated into this equation. So our x is going to be 50 million, and if we do the math, then we get our prediction. At least according to our model, right? On a chart, it would look something like this. We can draw a line up from 50 million and then predict how much it is that we're actually going to make off the movie. And it's going to be a little bit less than 3 times the amount that we invested. So about $148 million. Which is not bad, right? But how do we know if it's accurate? How can we measure how good our model is? So even though it is very, very simplistic, we can still ask the question of how much of the real world data it actually explains. And for that, we need some kind of measure. We need some kind of statistic. And the measure that we're going to look at is called R-squared, also called the goodness of fit. To look at our R-squared, we'll simply take our regression and we write regression.score. And within the parentheses, we supply our capital X and our lowercase y, our feature and our labels, and we hit Shift Enter. And here what we see is that the R-squared is approximately 0.55. This number here is the amount of variation in film revenue that is explained by the film's budget. And I gotta say that 55% is actually pretty good. Because think about it this way. Our very simplistic model with a single feature, namely the production budget, can explain around 55% of the variation that we see in worldwide movie earnings. I'd say that's pretty good news for a first try. But of course, we should be a little bit cautious reading into this model too much, because we've still got a lot to learn. For example, how would our model do if we added more features, like how long it took to make, or if it's a sequel? Would we get more realism? Would it make our model perform better and make our predictions more accurate? And perhaps we should evaluate our model not just on the data that we used for training it, but on new data, data that it hasn't seen yet. And also, what if the relationship that we have here is actually nonlinear? What if we somehow need to transform the data to get a better fit? So in a way, our analysis has left us with a lot more questions that we should investigate. And we will do just that in the upcoming modules. Well, you got started on the first project and you went through the whole data science workflow. You've gathered the data, you've cleaned the data, you've visualized it, and then you ran a machine learning algorithm, and then you've evaluated the results, and you've even made a prediction. But this is only the start. We've got a whole lot more ground to cover, and we'll dive deep into a lot of these concepts and the techniques that we've introduced here. In the next module, we're going to install Jupyter, and we're also going to learn a little bit more about regression. But the real focus will be on learning more Python programming. From there, we're going to learn about gradient descent and how optimization works for many machine learning algorithms that we're going to encounter. And after that, we're going to use multivariable regression and predict some real estate prices in Boston. From there, we're going to build an actual spam filter from scratch using a naive Bayes classifier. And then we're going to take it up a notch, and we're going to dive into deep learning with neural networks and TensorFlow. So for all of that and more, I'll see you on the next lessons.